Hi students, MCQ 20. A given sample of an ideal gas occupies a volume V at a pressure P and absolute temperature T. The mass of each molecule of the gas is small m. Which of the following gives the density of the gas? It's a very interesting and very important problem. It has been asked in the year 2016 NEET medical entrance exam, and it is also repeated in many other competitive exams. Now my dear students, ideal gas equation is very important to solve such problems. See, what is ideal gas equation in many forms we have studied? PV is equal to mu RT. This is one equation where mu is the number of moles of the gas. R is the gas constant. Now this PV is equal to NKT. This is another equation where N is the total number of gas molecules present inside the container. Understand? So K is Boltzmann constant. So this equation I am going to use. So from this, volume of the gas can also be written as what? NKT divided by P. So this is our equation number 1. The volume of the gas V is also written as what? NKT by P. Now, what is capital N here? It is the total number of molecules. If you divide this by volume V, you will get N by V is equal to small n. Small n is called number density. We have studied, is it not? So here capital N means the total number of molecules. Okay, then what is given here? Small m is the mass of one molecule. So this is what? Mass of one molecule. Then I will take rho. This is the symbol for the density of the gas. So density of a gas, that is equal to what? Total mass divided by the total volume. Is it not? So rho density is equal to the total mass of the gas divided by total volume. Okay. The question is, which of the following gives the density of the gas? So I will start from the density now. So density is equal to total. If small m is the mass of one molecule, and if there are n number of molecules, then this total mass is equal to number of molecules into mass of each molecule divided by V. Understand? Divided by V. So this V can also be written as N into M divided by rho, and this is our equation 2. So V is also equal to N into M by rho. So look at equations 1 and 2 now. Compare equations 1 and 2. Left hand sides are equal, so I am going to equate the right hand sides. So N into M divided by rho. This must be equal to NKT by P. So this is the NKT divided by P. So the number of molecules get cancelled each other. So M by rho is now equal to KT by P. Now taking reciprocals, I can also write this as what? Rho by M is equal to. So density rho divided by M is equal to P divided by KT. Therefore, density rho is equal to M into P divided by K into T. So, comfortably, we have got an expression for density in terms of the mass of molecule M. So, which of the following gives the density of the gas? You see here option B is MP by KT. So this is the correct answer. Therefore, option B is the correct answer. So this type of problem is entirely new from the regular equations which we used in the previous problems. I hope you must have understood this well. Fine.